CBT Nuggets JNCIA Series Layer 2 and Layer 3 Exam Essentials. You know, I was actually going to have this be two separate nuggets, but I really want to get this material, kind of down your throats and moving on because I am so excited about our lab that we have coming up that we're going to be doing our routing with, because it's really going to prepare you for that job at Nugget Lab. You're going to walk into that scenario, you're going to understand right off the bat how to get those routers talking to each other, and I'm really, kind of chomping at the bit to get into that lab, but I've got to take things, one step at a time. Now, this particular nugget here, if you're not planning on taking the exam, well, then you could literally skip this one, okay? However, I think you'll pull some interesting information out of this. I'm going to be tracing a packet through the Juniper device and talking about what happens at Layer 2 and Layer 3. Remember, all those devices can really do switching and routing, right? They're Layer 2 and Layer 3 devices, even the security appliance, okay? So we're going to do that. You'll learn a lot from that about the architecture and the behavior, and that will come in handy, especially later on when we look at things like class of service and routing policy. But then we're going to hit the Layer 2, the OSI Layer 2 Exam Essentials and the Layer 3 Exam Essentials. And I really want to encourage you, if you have not gone through those nuggets I recommended to you by Jeremy Chiara or James Conrad or myself in the Network Plus series, make sure you do that. I'm not going to reteach how a switch learns and builds a MAC address table. I'm not going to reteach IP addressing, okay? I want to make sure that you have those basic concepts under your belt, because what I'm going to do here is, once I get through this initial packet tracing through our device, I'm really going to touch on the things you need to know and my excellent shortcuts for passing this entry-level JNCIA exam. That's my goal, and we want to get through this nugget so we can get on back into the configuration of our Juniper router in the Junos operating system. Okay, since we're talking about Layer 2 and Layer 3 essentials, let's start lower in the OSI model and start with Layer 2 and work our way up. And the best way to start at Layer 2 is to go to the switch. Now, the advantage of the switch is you can take a switch port like GigE000 and say, I want you to function as a Layer 2 port or a Layer 3 port. Let me show you what I mean. Let's go ahead and say we want to set the interface on this one, and we'll say we're going to do GigE000, and the first thing we have to do is do a unit, okay? A unit, and this is what makes Juniper and Junos kind of special, is that every interface has to have a logical interface assigned to it, okay? It's like a sub-interface in the Cisco world, but every interface has to have at least one logical interface. So we're going to have at least unit 0. Now what that means is, for example, on a routed interface, I could have multiple units or sub-interfaces that could represent VLANs, and I could actually, route between those VLANs. We'll talk more about that later, but I have to have at least unit 0. And if it's a point-to-point interface, for example, or it's an interface that connects to, let's say, an Ethernet, like an Ethernet switch, it's going to be unit 0. Now the next thing we have to do is say, what family? Now on this switch, on this EX2200, if I put a question mark in here, you can see that I can go ahead and I have options. I can make this GigE000 interface. I can leave it at Ethernet switching, which is the default, by the way. It's a bridge, okay? Ethernet switching or Layer 2 port, or I could say, you know what, you're INET. INET is INET version 4, so you'd be a routed port. I could even do INET 6, which says, you know what, you're an IPv6 port. So on this switch that has 24 ports, I can make some of the ports Layer 2 Ethernet switching ports, and I can make some of these routed ports or IPv4 and put IPv4 parameters on them, right? Because remember, IP is at Layer 3. So I have that functionality, I have that flexibility. And so why this is important is because what we're going to look at first of all is we're going to look at an interface on a switch that is configured with the default or of the family Ethernet switching, so a Layer 2 port. And then we're going to see what happens as the packet moves through this particular device, and if we have to pass it up to a Layer 3 process or a Layer 3 interface, okay? So we're going to kind of take a step-by-step approach to this, and we need to understand this from a fundamental, foundational standpoint. It'll make everything much clearer moving forward. Okay, so let's say this is that port right here Let's say this is that port gigabit 000, and then dot 0 is unit 0, okay? And it's configured as an Ethernet switching port, right? So we have this packet or frame coming into this interface. What's going to happen? Well, this Ethernet frame is going to come in here, and it's going to go through the header extraction phase, where we're going to strip away the header. So here is the header being stripped away, right here. So if you look at this header, it gets stripped away, and here it is. The original packet, though, the data packet, so basically everything that's layer 3 through 7, is going to go into this shared data buffer switch fabric. So, as part of the packet forwarding engine, what happens here is our transit traffic is going to be written into this shared memory area one time, okay? One time and one time only. And then, depending upon whether it's just going to be switched or whether it's going to be routed, we may need that same frame again to be read from that memory location multiple times, for example. If it's a multicast packet, for instance, if it's a multicast packet, we will read it multiple times from that location when we're going out. So I want you to look at all these blue boxes here. I'll put a line across here. So all these blue boxes above is what we would call the ingress traffic, okay? So I'll just put in, or how about ingress? Everything that's green here is going to be what we call egress or outbound traffic. So if you've ever heard about multicast traffic, whether it's a multicast frame or a multicast packet, what we do is we just read the same one instance of the data multiple times out of the switch fabric. We don't have a bunch of the same data frames moving through our device. So all that really is happening here is we're dealing with the header information. And that's something you may not think about. We talk about frames moving through a switch or packets moving through a router, where really what happens is that initial data gets stripped away and put into a buffer, identified, and all we're really operating on is the metadata, okay? The data about that data or this header information. So the next step is what we call the VLAN classification stage. This way we're going to find out if it belongs to a VLAN, okay? And remember, this is a switch, so this frame could belong and be identified as a member of a VLAN, VLAN 1, VLAN 50, up to VLAN 4094 actually. It gets classified as being a part of a VLAN. So it'll be tagged, okay? There'll be a tag on it. At this point, it'll move to the layer 2 firewall or policer process. So this could be a port level firewall filter, or if it's a VLAN tagged frame, it'll be a VLAN firewall filter. And we can do all kind of stuff here that we'll learn about later. Now, if the packet is not dropped during this firewall phase or this policing stage, then it's going to send it to this next fourth step, number 4, the spanning tree protocol check. So what happens here? Well, if our port is not in the forwarding state, okay, with spanning tree protocol, as you'll learn later, only the ports that are forwarding are going to continue to process the traffic. So if it's not in the forwarding state based on the spanning tree protocol, if I'm trying to prevent a loop, then STP will block the traffic. Okay, well, let's say it's in a forwarding state. So let's send it on to the bridge engine. This is where we do the learning of the MAC address, right? The source MAC address is going to be matched against a list in the learned MAC address table or the bridging engine. If no entry is found in the bridge table, then this bridging function will redirect that packet to the control plane so it can obviously learn. The next thing it wants to know is this packet destination one of the switch's own MAC addresses? So was this frame and the packet itself, was it destined for this device? If the answer is yes and a match is found, then it's going to be sent up to the layer 3 process or the routing process. If the answer is no, it's not destined for this particular device, it gets sent down into the egress processing, where the first thing it runs into is the layer 2 multicast replication if necessary. Okay, so what is this all about, this multicast replication here at this particular egress phase? Well, if this layer 2 frame has to be sent out of more than one logical interface, for example, it's a broadcast destination MAC address, all Fs, or the multicast destination MAC address, or maybe it's unicast that hasn't been learned yet, so it has to be flooded out a bunch of interfaces. Well, at that point, we'll do our multicast replication here. Here, this is our class of service processing. Talk more about that. Things like priority scheduling, prioritization, things like that. Here at step 8, we're going to rewrite the header. It's also referred to as marker rewrite. That's beyond the scope of this course. Here's our layer 2 outbound or egress firewall. All we could do here is basically VLAN filtering, or if the packet was at layer 3, we could do layer 3 filtering. We also call that firewall filtering. Okay, so now we finally repackage or reform that layer 2 frame, and of course we can see that things maybe have changed in it. At let's say step 7 or step 8, we take the original data from the buffer switch fabric, we rewrite the layer 2 header, and boom, send it outbound on the egress interface. And by the way, if this interface gigabit 000 were configured to do routing between VLANs on the same physical interface, the traffic could be entering and exiting on gigabit 000, not necessarily a separate physical switch interface. Now, let's go back up here. If the destination MAC address ends up matching an address that's owned by this actual device, in this case a switch, then we're going to send it up to the layer 3 process, or what we call layer 3 routing. Let's take a look at what goes on there. And by the way, it'll be a simplified version. We'll get more in depth with that layer 3 process as we progress along in our knowledge. This information right here, though, will really come in handy when you get to the JNCIS, the next series, where we really focus on switching a lot more. So it'll be a great review. Okay, so let's say the destination MAC address was matched in the table against an interface on this particular device, this switch, this multi-layer switch, or this router. So we're going to come from the layer 2 process up to the layer 3 process, or up to routing. Now, why would the destination MAC address be this device? Well, there could be a static route pointing to this device. This could be the default gateway or gateway of last resort for some network going out to the internet. Or this could be part of a series of routers, and it can just be another hop on its way to the destination. Either way, some downstream router forwarded a packet to an interface on this device so it could be processed and possibly routed on to another router along the path. That's how it gets destined for a MAC address that this router or this device owns. So it comes up from layer 2. Here, we're going to apply the inbound layer 3 firewall and policing. We'll do a route lookup. And by the way, this is going to be the same if this were let's say, a routed VLAN interface, or if it was a native layer 3 interface, let's say on a router. So once our device gets through the access control list that operate at the IP layer, as well as TCP and UDP, we go to the route lookup phase. And by the way, it only gets to the route lookup phase if it passes this first step here, right? It could be dropped by the firewall or dropped by the policer. So what do we do in the route lookup phase? Well, here we're looking up the longest match, okay? A longest match lookup against the destination IP address to figure out what outgoing interface or next hop, or maybe we're going to take some other firewall action. Because remember, based on that longest match lookup, the longest CIDR prefix, 24 for example, based on that information, we might want to send it through an outbound or egress layer 3 firewall or policer. Now what you see down here is that there's a possibility that we could be doing layer 3 multicast replication. We'll talk more about that as we get farther along. But once we pass the route lookup process, go through the egress layer 3 firewall policer, we're going to go back down to layer 2 because we have to obviously go through the egress processes at layer 2 so that ultimately we can get another frame, header, and trailer around that data and then send on to its destination. Now I have simplified this a little bit because if this traffic is TCP, right, we know that it's going to be what we call session oriented or connection based traffic. So there's going to be a session. So this traffic could already be part of an existing session or it could be a brand new session. And so later on as we learn more and more, we'll get deeper into some of the sub-processes that happen when a TCP packet is either the first packet of a session or if it's part of an existing session. A lot of really cool stuff goes on there, but it's mostly security related. Okay, so we'll focus on that as we get a little bit more into security into some of our other Juniper nuggets. Okay, now that we have that walkthrough at layer 2 and layer 3 under our belt, let's look at some exam essentials starting with layer 2. Now, some of the first things you have to know, and again, these are all things I want you to know to pass the exam, okay? The JNCIA exam. So for example, you need to know, and you may already know this because you've followed my advice and you've gone through and you've looked at some of the other supporting nuggets from Jeremy or James or myself, but you need to know the broadcast MAC address, which is basically everything turned on, okay? All the hexadecimal turned on, all Fs, okay? So all 6 segments are going to be F. Just like the layer 3 broadcast address for IP version 4 is 255.255.255.255. And there's dots in there, of course. Now, the multicast MAC address is a valid range, and it basically starts with 01:00:FE. That's all you need to know. Okay, so on the exam, make sure you know the broadcast MAC address looks like this, and that the multicast MAC address, where the OUI part of it, the organizational identifier part of it, or the first 3 segments are 01:00:5E. Now let's talk some more about layer 2 broadcast frames. There's 2 things I want you to know about these types of frames. Broadcast frames are processed by all the nodes or all the devices on the same VLAN, and broadcast frames are relayed by switches over trunks or aggregates to devices on the same VLAN. So if I had 2 switches and they were connected together, and I had, let's say, 2 workstations here and 2 workstations here, and they're on the same VLAN, okay, so here's my workstation on these ports, and they're on VLAN 11, then a broadcast frame from this device will go to all of the other devices on the same VLAN, even if it goes across multiple switches. Here's a question for you. What does the switch, the EX switch, use in order to forward a frame, a Ethernet frame, to its destination? Well, it uses the destination MAC address. Got to remember that. Remember early on in this Nugget series, we talked about collision domains. We talked about hubs, for example, which were one big collision domain. Well, something to remember is this. We're using switches now, right? So if you're using a switch, it's important to remember that the collision domain is actually only going to be the switch and the device that's directly connected to it. So if you have a switch here and you have, let's say, 24 ports, that's my ellipsis, 24 ports, each device that's connected is its own collision domain. Okay, so I did ipconfig on my system here. I want to reiterate one more thing to you about MAC addresses, and I alluded to this earlier when I was showing you the multicast MAC address. You need to also remember what portion of the MAC address is represented by the OUI, okay, the organizationally unique identifier, and that's these first three parts here. So 002481, or if it's on a switch or a Juniper router, it'll be colons, 00:24:81. That first part, that's the OUI, okay, remember that. Something else you're going to want to know is this. This is the IEEE 802.1q frame. Okay, so here's the destination MAC address, source MAC address. Here's the .1q or the VLAN tag information. There's a couple of fields here you want to know about. For example, there's a type field and a frame check or a checksum field. So in addition to the destination MAC address and the source MAC address, remember there's a type field and there's a checksum or a frame check field. We'll learn more about this .1q tag when we get to JNCIS. Now, one more thing about collision domains. Remember, if it's a switch, okay, the collision domain is the device and the switch. If a hub is used, which, you know, it may be a wireless hub, the collision domain is going to be all the devices that connects to the hub. Don't forget that. And don't forget this from earlier, I mentioned this. If this device is a hub, okay, so that means it's really just a one internal Ethernet bus or segment. If two devices, let's say this device and this device, send a frame at the same time, it's going to cause a collision. What's going to happen? Both of the devices are going to stop transmitting. They're going to wait for a very short but random period of time. Make sure the wire is idle, then they'll retransmit. Also, both devices are going to send a jam signal to tell other devices on the hub that there was a collision. Okay, that pretty much covers our layer 2 exam relevant pieces of information, I think, with what I showed you earlier on in the series and these extra tidbits. You're prepared for the JNCIA exam, and you know, of course, if you use the additional resources from Jeremy and James, for example, you should be doing just fine. That should carry you through from this JNCIA and beyond. Let's go ahead and take a look at Layer 3 Exam Essentials. Okay, my exam tips for Layer 3 are going to focus on IP subnetting and all the questions that would go into IPv4 subnetting, as well as maybe some ICMP type questions that you might see. Now, we know that routing occurs at layer 3. I'm not going to get into any routing here, okay? That's upcoming in this nugget, but I want to make sure that you're not going to get burned in any subnetting questions, okay? And there will be a good handful of that on this exam. And so hopefully you used your resources, but I'm going to give you some sample questions, okay? These aren't actual test questions, but they're my own sample questions that cover some of the things you need to know. Now, the first thing I want you to do when you go in there and take your exam, and I do this, let me fix my microphone here, I do this on most of my exams because, you know, when I'm doing addressing out a network, look, I'm going to use a subnet calculator by SolarWinds or subnetting charts to do VLSM and stuff. I'm not going to sit down and do it all in my head. I could. I'm pretty good at it, and I've been doing it for a long time. But my time is too valuable. So, and I'm not trying to impress anybody. I'm not Mozart, okay? I'm practical. So one of the first things I'm going to do is when I go take an exam, they're going to give me a piece of paper and a pencil or a whiteboard with a marker, right? So I'm going to walk in there, and I'll probably, you know, just to be ethical, I'll wait for my first IP subnetting question, okay? They don't really like for you to walk in there and like map all this stuff out before the test starts. So I'll wait for my first subnetting question, and I'm going to put 8 tick marks, okay, on this paper or this whiteboard. This is going to represent, let me go a little bit farther away. This is going to represent an octet, okay, 8 bits. Now, this octet could be the third octet because I'm doing my subnetting in the third octet, which I might be in a larger network. This represents that third octet. It might be the fourth octet. If I'm working with a smaller enterprise, I'm doing my subnetting in the fourth octet. I want to make sure that I memorize the values of these bits. So the highest order bit has a value of 128, the next order bit a value of 64, then 32, then 16, then 8, then 4, then 2, then 1. So I'm going to write that out. I'm going to write 8 bit marks and then the value of these. Then what I might do is this. I might do the traditional subnetting. Now, I don't really have to do this usually for a Juniper exam because Juniper uses CIDR. They use CIDR or CEDAR representation like /22 or /30. But just in case, I'll put .128 and then I'll put .192 and so on and so forth. Now what I'm doing is I'm saying 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. And then 252, .252, and .254, and then 255. Now this is the traditional subnet mask, okay? And we know that we use the subnet mask to differentiate the network part of the address to the left from the host portion to the right, okay? So I've got that. Then I'll go and say, well, let's now create our CIDR representations. Now we know this could either be the third octet here or the fourth octet. So I'll start with the third octet. If it's the third octet, this is going to be /17. And then 18, 23, and then of course /24. What if it's the fourth octet I'm doing the subnetting in? Well, then it's /25 and so forth. Okay, so these are our CIDR representations, and again, as we know, the longer the prefix, that's the longest match when we're trying to match in our routing tables, of course, too. So I will write this out. Now, do I write all of this out? No. Okay, I can pretty much do it with just simply writing out the bit values and maybe do the /17 and /25, and then I can work from there. This is good for you as a habit to write this out because we're going to use this now to answer all of our subnetting questions, okay? Believe it or not. So let's look at some sample questions you might see on the exam. Okay, so your first layer 3 test task, say that 3 times fast, is going to be what we call binary equivalence. So you are presented with a number, a decimal number, and you have to identify what the binary equivalence is. And I'll give you some shortcuts here, of course. So let's say they give you, I don't know, number 94, okay? They give you 94 and they say, what's the equivalence? There'll be, 4 or 5 options to choose from. Some shortcuts right off the bat are this. If the lowest order bit or the last bit in the octet is turned on, or it's 1, well, you know that that's an odd number, okay? So if the last bit's turned on, you know that whatever answer has that in it will not be correct. Also, since the first order bit, the high order bit, has a value of 128, if that's turned on, well, then you know that any answer that has the first bit turned on can't be right, okay? Because it has to be at least 128. So we can eliminate those 2 options right off the bat. So since 94 is less than 128, we would have to start with that. Then we ask ourselves, okay, well, is 94 greater than 64? The answer is yes. So we're going to turn that bit on, put 64 over here, and subtract it, and we'll have 30 left over, right? Is 30 greater than 32? It is not, so we turn this bit off. Is 30 greater than 16? Yes, it is, so we turn this bit on, right? So we subtract 16, and that gives us 14. Is 14 greater than 8? Certainly is. Turn that bit on, subtract 8, that gives us 6. Is 6 greater than 4? It sure is. Turn that bit on. Subtract 4, 2. Is 2 greater than or equal to 2? Yes, it is. On, off. So the correct answer would be 0, 1, 0, 1, 1, 1, 1, 0. Or look at it this way. 64 plus 16 is 80, plus 8 is 88, plus 4 is 92, plus 2 is 94. Let's do one more, okay? What is the equivalence, the binary equivalence of 149? Okay, well, 2 things. Number 1, the first bit's going to be turned on because 149 is greater than or equal to 128. So we're going to turn that bit on. Also, it's an odd number, so the final bit will be turned on. Okay, so the first thing you can do is look at the answers and look for an answer that has the first and last bit turned on and get rid of the rest of them. Okay, that'll narrow it down. So 149 is greater than or equal to 128, right? So let's go ahead and subtract. That leaves us 21. Is 21 greater than 64? It is not. Is it greater than 32 or equal to 32? It is not. How about 16? Yes, it is. We need that bit. So turn it on. That leaves 5. Is 5 greater than or equal to 8? It is not. Off. 4? Yes, it is. On. That leaves us, of course, with 1. Turn that bit off, and we know this bit's turned on. So 1, 0, 0, 1, 0, 1, 0, 1. I think that was a Rush song from the 80s, maybe. No, I don't know. But that is the equivalent of 149. Okay, now granted, that binary equivalence thing, it's not really an on-the-job skill you're really going to need. However, when you get into a Nugget lab, it's quite possible you may have to readdress your network because you're growing or you're merging or you just don't like the way that the previous person did it. So this next skill set we definitely have to have. Let's say you've been assigned the network. We'll say it's 10.10.13.0/24. Okay, so we know that with the 24 CIDR prefix, the first 24 bits represent the network and the last 8 bits represent the host on that network. So we have 2 to the 8th power minus 2 hosts. That's 254 because we can't use the first available one, that's the network, and the last available one, 255, is the directed broadcast on the network 10.10.13. Okay, so here's your task. We want to segment this network, this 24-bit mask, into a network where we have 60 subnetworks. Okay, right now we only have one subnetwork. Okay, network 10.10.13. We want 60. So how do we do this? It's very easy. You go up here and you go, okay, if we take, we're going to basically we're going to steal bits, right? We're going to move this CIDR prefix over. Right now we got our CIDR prefix right there, right? We're going to slide it over and we're going to steal some bits to create more subnetworks. Well, if we steal 2 bits, that's 2 to the 2nd power, that's 4. If we steal 3 bits, that's 2 to the 3rd power, that's 8. You with me? We have to steal 1, 2, 3, 4, 5, 6, 7. Actually, we need 6 bits because 2 to the 6th power is 64. Okay, so that gives us 64 subnetworks. So we need to move our CIDR prefix down to right about there. Okay, well, how do we determine in this 4th octet what network mask we need to assign? Well, we need the other table, the rest of the table. So we are subnetting the 4th octet. So we're going to go down here. We need to use this. So if we go down and we steal 1, 2, 3, 4, 5, 6 bits, then now we're going to use the /30 prefix. Okay, so that handles the, what prefix do I need or what subnet mask do I need to accommodate a certain number of networks. But what if they come at it the other way? I need to accommodate a certain number of hosts on my network. What kind of mask do I need? So let's say that you have on your network, you have to support 1,000 hosts. So you need a subnet mask to create a broadcast domain to accommodate for those 1,000 hosts on the corporate network. Not a very uncommon thing, by the way. Well, we know that we're going to have to subnet into the 3rd octet. Why? Well, because if we do a /24, that only gives us 254 hosts. So we're going to have to supernet over into that 3rd octet. So let's say that this here is the 3rd octet, and of course this is our 1, 2, 3, 4, 5, 6, 7, 8 of the 4th octet. So we know we're going to have to go this way and supernet. Well, this is pretty easy. If taking a 24 mask gives us 254 hosts, okay, if we supernet and we go one more this way, which by the way would be /23, right, instead. Well, if you just double this, okay, so 254 times 2 is 512, okay, and we know it doubles, right? 1 doubled is 2, doubled is 4, doubled is 8, doubled is 16, okay? It's not rocket science. So that's not going to do it for us. 512 is not enough. But if you double it again and you go and you supernet up here at this bit, that's going to be 1,024. Well, that's enough, okay? So we know that our CIDR prefix or our subnet mask would be /22 now. That'll handle the I need this many hosts, okay? So basically we're saying we need 2 to the 10th power. 2 to the 10th power is 1,024. Prove it, you say? Well, 2 to the 8th power is 256. Now remember, we can't use 256 because we have to remove 2 because the first one is the network and the last one's the broadcast. So we can't do, so that's the deal there. Clear that out. So 2 to the 9th power, like I said, we double it, 512. Okay. Well, 2 to the 10th power, like I said, is 1024. Now, you might be asking, can I use the calculator on the JNCIA or JNCIS exams? You know what? I don't know. I never use it. I never use the calculator. I think Microsoft lets you. I don't think Cisco does. So I would assume not, right? So you'll need to be able to answer any of those questions to say, okay, what type of mask or CIDR prefix do I need to accommodate this many networks based on this address? And what type of prefix do I need if I need this many hosts based on this address? So you have to be able to answer both of those questions. That's very real world, by the way. Now, at Nugget Lab, we would use a subnet calculator or some type of chart to do this, but on the exam, you have to be able to do it in your head or using this little chart that I generated for you, okay? Now, if you get lucky, you'll get a question like this that'll say, what network mask or what CIDR prefix is the equivalent of, let's say, 255.255.240.0? Okay, that would be awesome if you got that. So we're subnetting in the 3rd octet, right? So we know on our chart that we made, this is the 3rd octet, this is the 4th octet, right? So this is an easy one. You just go to your chart that you created, you go, oh, okay, here's .240, it's /20. So that would be the correct answer, okay? If they say, what's, 248.0, look at your chart, /21. That's the correct answer. And eventually you'll be able to do this in your head, okay? But for the exam, let's just get there. And also, don't let them trick you with the usable hosts thing. So for example, let's say you have a network of 172.30.100.0. That's your network, /22. So your subnet mask is .252 in the 3rd octet, /22. So we know that we're actually going to have available to us for the host 2 to the 8th, 9th, 10th, right? What I showed you earlier, 2 to the 10th power hosts. Well, 2 to the 10th power is actually 1024, right? But remember, we can't use all those. So we always have to subtract 2. So the correct answer is 1022. Don't get burned by that. In other words, if you're trying to figure out the usable hosts, always subtract 2. We don't do that on the network, okay? Just on the host side. Also remember, by definition, the subnet mask, which we're looking at here, the subnet mask designates the part of the IP address that represents the network prefix, okay? This is the network mask. This is the CIDR or CEDR representation, classless interdomain routing. And that basically tells us of the 32 zeros and ones, which of the high order bits represents the network. That's the goal. You could also think of the network mask this way. It tells the system which network an IP address belongs to, either an end system or a router or a layer 3 switch or a firewall or a security appliance. Anything that basically operates at layer 3 has a routing process. Okay, here's one for you. I have my internal network. It's 192.168.1.0/24. This is a small business with, again, 254 hosts. I need to break this down. Let's say it's a school, okay, a small school with different classrooms, and I want to have a minimum of 12 subnetworks now, each one with a minimum of 12 hosts, okay? Could you tell me the right subnet mask, the right network mask or CIDR prefix to choose for this? Now, of course, we're going to be subnetting, so we're going to be increasing this number. We're moving this way, right? So this is easy. 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, so I need to borrow 4 bits, okay? That accommodates for my 12 hosts. 2 to the fourth power is 16, so I need to borrow 4 bits. 1, 2, 3, 4. So right there is my demarcation point. So /28 is going to give me 2 to the fourth power networks, which is 16, which accommodates for my 12 networks, and 2 to the 4th power host minus 2. 16 minus 2 is 14. That accommodates for my 12 hosts. So now I'll change my mask to 28, and I would address my host accordingly. Now remember, when I do this and I subnetwork like this, that's going to actually have a result of reducing the number of hosts that I have. Because every new subnet I create, I have to have another network and broadcast address in that subnetwork. So effectively, I'm kind of reducing my overall number of hosts that I had originally. The more networks you create, the fewer hosts you create. Okay, the final subnetting thing we have to be ready for the exam, and like I said, in the real world, we could just use a subnet calculator and we could figure this one out. But that's the usable hosts problem, okay? In other words, based on the prefix or the subnet mask, what is the range of usable hosts, okay? So, here we go. Let's say you have a network that is going to be 92.4.128.0/19. Well, this is where block sizes come in. Obviously, we can see here that if we're doing /19, that we're subnetting in the 3rd octet, right? This octet, the 3rd octet. So basically, our demarcation point is right here. Well, one thing we need to do is figure out the block size. And so since /19 corresponds to this 32-bit, our block sizes are going to be in blocks of 32. So our networks are going to be 94.4.0.32.64.96.128.160. These are blocks of 32. So those are our networks, our usable networks. We know that because we have our CIDR prefix as /19, and it's on the 32-bit here in the 3rd octet. So those are our networks. So they're basically saying this is the 128 network. Okay. So what are the usable hosts? Pretty easy. Okay. We can't use 128.0 because that's the actual subnetwork, right? But we can say 128.1. So that's going to be the first usable one. Okay. Well, how do we figure out the end of the range? Well, what's the next subnetwork? Well, it's 160, right? Because 128 plus 32, that's our block size, is 160. So 160 is where the next network begins. So this cannot be 160. So it's going to be 159, and the next number underneath 160 is actually 159.255, right? But we can't use 255 because that's the directed broadcast on the 1.128 network /19. So it needs to be 254. So our acceptable range, our usable host range, would be 92.4.128.1/19 through 92.4.159.254. Okay, 159.255 is the directed broadcast. The one above that is 160. Make sure you can see this is a 9. Is 160.0. Can't use that. That's the next subnetwork if we're using a /19 prefix. Okay, that's probably the most difficult type of thing to figure out, and really what you want to do is you just want to look at what is your CIDR representation, what is your subnet mask, what is your prefix. If you're subnetting in the 3rd octet, is it /23 /22 /20? If you're doing it in the 4th octet, is it /27 /28? And then you just look up and say, okay, well, wherever this prefix is, what is the value of that bit? Okay, what is the value of that least order bit of that network? Right? So if you look at /19, the value of the least order bit in that network is 32. That's going to be your block size. So you know that your networks are going to be multiples of 0, then 32, then 64, and so on. If I moved it down here, oops, sorry about that. Let me clean that up. If I moved it down here and said, okay, let's take /20, then it's going to be blocks of 16. So my networks are going to be .0, .16, .32, .64, and so on. And so you can figure out what your usable hosts are based on the address they give you, and make sure you always remember that the first available one you can't use, and the last available one in that subnetwork is the directed broadcast, and you can't use that either. Okay, the final layer 3 exam essential I want to give you is the ping command. Okay, and the ping command is different depending upon the platform. It's different on a Microsoft system, it's different on a Linux system, it's different in the Cisco iOS, it's different in the Junos. So if I go to my 2350 router and I do a ping command in operational mode followed by a question mark, I'm going to see the possible completions. The reason I'm showing you this is because there's a lot of things you can do with this ping, which by the way is the ICMP protocol, echo request, echo reply. So a ping is actually going to be 2 ICMP messages, echo request and then echo reply. Now, a couple things you might need to know for the exam is if you issue a ping command to a particular IP address, and you could even source it from a particular interface, right? You could say, what's the source address? So that's source down here. You can ping and you could say bypass routing. You may need to do that if you have to bypass the routing table, if you don't actually have a routing entry for it. So you can do a bypass routing entry. You can also do a count, because by default, it's just going to keep going. Okay, I think it shows you right here, 2 billion. So you're not going to wait for 2 billion echo requests, echo replies. And if you issue a ping, it's not going to stop. Okay, it's just going to keep on keeping on. So I'll do Control C here. For example, ping 192.168.3.10 and no route to host. By the way, notice it just keeps on going continuously. Okay, that's not a good thing. So Control C will stop it. Let's try this. Let's say ping bypass routing. So we bypass the routing, that's okay, because I have no static route in the routing table yet. But you can see now I'm actually getting to 3.10, which is this management station, right? And it's getting 64 bytes, and it's just going to continue to keep on going up to 2 billion of these. I don't want 2 billion, so I can just say Control C. Okay, that stops it. So I could also do ping, and then we'll do the bypass routing thing, and we'll do the 192 address 3.10 and see what our options are. We could say, well, this time let's do a count of 4 or 5, which is typically what you do on other systems. Okay, or we could say rapid. It defaults to 5, so it sends 5 rapid requests. That's pretty interesting. Something else you would do if you're testing your network or you're testing your intrusion prevention system is you can say, I want to change the size, because if you have a large ICMP packet size, that actually triggers certain attack signatures. Okay, certain attacks on your network will increase the size of the ping. So let's go ahead and say I want to do the rapid and issue that, and boom, there you go. Very quickly, 5 rapid pings. And the 5 exclamation points means that they were all 5 successful. So that might be a quick thing you might want to do, but just remember for the exam, remember the bypass routing option, so you can ping something even if it's not in your routing table. Remember the rapid, remember the count, okay, so you can do a certain number of count, 5, 10, something more practical. All right, there we go. All right, in this nugget of the JNCIA series, we looked at Layer 2 exam essentials and Layer 3 exam essentials. First, we traced a packet through a Juniper device, actually a Juniper switch, and then looking at Layer 2 and Layer 3, we'll delve in more to Layer 3 as we get through this particular nugget, and later on when we get into JNCIS, we'll get even deeper. We looked at some Layer 2 exam essentials, things you have to know for the exam, and Layer 3 exam essentials with my tips on IP addressing and subnetting, and also knowing some of the aspects of the ping command, echo request, and echo reply. Well, that pretty much does it for a couple of, what I would say theory-based nuggets with just kind of content we have to know to prepare us for our on-the-job activities at Nugget Lab and our exam. In the next Nugget, we're going to get back to the Junos configuration and prepare you for the types of activities you're going to do right off the bat when you go into Nugget Lab and you start working with interfaces and getting those devices to talk to each other and route to each other. Sound awesome? I'm excited about it. I hope you are. And I hope this CBT Nugget was informative for you. I want to thank you for viewing.